Welcome to a lesson with Dr. Powell. Let's look at a very simple test to see if something might diverge. Now, this is not a test to see if something converges. It's just a test to see if maybe it diverges. But um, and that's about it. So for sure to know if something diverges. I mean, as we add something up forever, okay, all these guys right here, what would happen if the absolute value of these guys, the terms, if the limit of this um, was not equal to zero? Well, let's think about what the partial sums would be doing. So we add up, so we add things up to a certain point, right? Then what happens the next point? Okay, then we add a little bit more onto it. All right. And then what? And then so we go up, and maybe we've gone down, and maybe we go up, maybe we go down, we go up, down. But see, if this thing doesn't actually tend to zero and get closer to zero, then that means that you can't really set an epsilon tolerance around a limit and be sure that we're going to be within there close enough, because maybe here we're adding something that's up here, and maybe we're adding something down here, or maybe right here, but we don't know that what we're adding is actually going to be less than epsilon, that we're actually, because it doesn't limit to zero, so it's going to be bouncing, or maybe it gets closer to something up here, maybe it has a limit, and maybe it goes to something up here, but eventually we're going to be outside the tolerance that we need from the limit when we're adding things up. So this is a for sure check. If the limit itself of the terms is not zero at all, then there's no way that this sum can actually exist, that the limit of the partial sums would actually work. We'd actually have a limit. So let's look at just a quick example of that. What if we did something like 2n plus 5 over 5n minus 2. And we did this as 10 forever. Notice that these terms right here actually limit to 2/5, which is not zero, which gives you a for sure reason right away. This is really just a way of giving a simple, quick reason why something might diverge just by glancing at it. Again, if this fails, I mean, has nothing to do with convergence. We just know that this diverges here because the terms themselves don't limit to zero. I mean, we can look at something like this. This series diverges even when the terms go to zero. So the terms going to zero doesn't guarantee divergence at all. But the terms not going to zero does guarantee divergence. So we know definitely it'll diverge if they don't go to zero. If they do go to zero, we don't know. So we can kind of think about it this way. If we have kind of the collection of everything that, let's see, where the limit, the terms go to zero, then inside of that is convergence, but it's not all of it. So, like if we're at a series that has this property of it going to zero, that doesn't mean that it converges. It still could diverge. So outside of this set, so this is the set of convergence, say, let's just kind of in our minds logically thinking, let's say this is all the series that converge. Everything outside of this inner circle is everything that diverges. Notice that outside this circle, where an goes to zero, we have sequences that don't go to zero. So if we're out here, then definitely we're divergence, because if we're out here, then for sure we're outside of this inner circle of convergence. So it really just doesn't, so if we're thinking about things logically, it doesn't say anything about knowing that the terms go to zero doesn't tell us that something converges. But knowing that the terms don't go to zero actually tells us that it diverges. Thanks for watching.